Hello everyone, welcome to this video lesson. In this video lesson, we are going to find out the height bounced back by a freely falling body when it is dropped from a certain height after certain number of the collisions. Let us understand what I mean by that. Consider a ball, a smooth spherical ball, falling freely with a zero velocity onto a solid floor from a height h. Let it strikes the floor where the floor is heavy initially in the state of rest. Even after the collision also the floor is still in the state of rest and the ball bounced back to a height h1. We know coefficient of restitution is defined as ratio of relative velocity of the separation after the collision to the relative velocity of the approach before the collision as per the definition. Being the second body in the state of rest, u2 is also equal to 0. But as where this is the u1 or initial velocity of the body just before the collision, this is the v1 final velocity of the same body immediately after the collision, being in the opposite direction, minus v1 has to be written. So coefficient of restitution can be written as v1 by u1. We have derived this even in the previous derivation also. Using kinematics equation, v1 can be written like root 2g h1, u1 can be written like root 2g h. So coefficient of restitution can also be expressed in terms of the heights as height bounced after the first collision by the height from which the body has fallen freely, root of h2 by h1, or in this case h2 is treated as h1, h1 is treated as h. So I got a formula now. In the case of first collision, height bounced back by height from which it has fallen. If I square this, that implies h1 equal to e square into h, where e is a constant called as coefficient of restitution. That is during the first collision. Let that ball has fallen back on the ground, bounced back to a different height, h2. So during the second collision, again I can apply the formula. During the second collision, basing on the definition, E as height to which it has bounced back and the height from which it has fallen under the square root. Squaring that, so h2 equal to e square times of h1. But I know h1 in terms of the basic height from which the body has started falling as e square h. So e square, the place of h1, again e square h. That is e power 4 times of h. That is e power 2 into 2 times of h. Whereas in the first case e power 2 into 1 times of h. So after the first collision, e power 2 into h, after the second collision e power 4 into h, or e power 2 into 2 into h. Let us say there is one more collision, and after the collision the ball has bounced back to a height h3. So after third collision or during the third collision, again coefficient of restitution can be written like root of height to which it has bounced back by height from which it has fallen. Squaring this, that implies, but I know h2 already, e power 4 into h, so h3 equal to e3, again e power 4 into h, so h3 is e power 6 into h, h3 is e power 2 into 3 into h. So after the first collision, you got a term e power 2 into 1. After second collision, you got a term e power 2 into 2. After third collision, you got a term e power 2 into 3 into h. That implies after n number of collisions, height bounced back by a body is e power 2 into n, where n is the number of the collision, into the h, where h is the height from which has started falling freely with a zero velocity. Like this, we can calculate the height bounced back by the body after n number of the collisions in case of a elastic collision. Of course, we are assuming like this collision is not a perfect elastic collision and E value is less than 1. If the collision is a perfect elastic collision, there is no loss of energy. Therefore, bounced back by the body, height bounced back by the body in each case equal to the height from where it has fallen itself. There is no difference at all. Every time the ball bounces back to its original height itself, because there is no loss of energy in that case. Thank you for watching. Keep coming back for more and more video lessons. Thank you.